Hello, class, and thank you again for watching and checking in your answers. Now, again, my usual disclaimer is that you should have the assignment completely done and simply just checking again that your answers are in fact correct, okay, and fixing any mistakes you might have accidentally made so you don't uh, get anything wrong because of careless mistakes. Now, on the first example that we have, again, if you remember in the class, the difference between this one and we did before is that on these absolute value equations, the complex ones, is that on these examples, you already simplify the absolute value. So we're looking for a number, again, that's inside here that can equal to 36. Well, only possibilities is positive 36 or negative 36. So what we're going to do is get what's inside the absolute value of 10v plus 4 and equal it to the two cases that either this is equal to positive 36 or that 10v plus 4 is equal to negative 36. And what we do there is that we treat each equation independently and we solve for each variable. So we'll start by this equation. We'll start with this equation here. And we will subtract 4 from both sides. Using inverse operation, we would have to subtract. So then we get 10v is equal to 32. 36 minus 4, yes, is equal to 32, sorry. And then divide by 10. Now we're going to get decimal 3.2, but let's leave it in fraction form. So in fraction form, 32 divided by 10 can be reduced. They both have a factor of 2, so I can divide both of them by 2. So 32 divided by 2, that's equal to 16, and 10 divided by 2 is equal to 5. So this would be the reduced answer. Now that is not the only answer that exists. Again, we have another equation that we need to consider, because again, the absolute value could be, we can take the absolute value of negative 36. The absolute value of negative 36 is also equal to positive 36. So that means that the 10v plus 4 could also possibly equal to negative 36. So if we solve for this equation and we subtract 4 from both sides like we did on the previous one, we get that 10v is equal now to negative 40. And dividing both sides by 10, we get that v is equal to negative 4. So these are the two possible values that we can plug in for v. If I plug in for the variable 16 divided by 5, I get that all of this is equal to positive 36. And the absolute value of positive 36 is 36. But then the same thing would happen if I was to plug in negative 4 right there. If I multiply and I plug in negative 4 for the v, then all of this is equal to negative 36. And the absolute value of negative 36 is equal to positive 36. So both of those two numbers work out. So that's why we end up with two possible solutions. Again, not the same number, but still two different values, all right? But that still work. And that's again what we're going to do with all these other examples. So for number 2, we're going to do the exact same thing. The absolute value is isolated. So we are going to get what's inside and equal it to both positive 41 or either 7r plus 1 is equal to negative 41. And we're going to solve the two equations. So we'll subtract 1. So the inverse operation indicates that we have to subtract 1 from both sides. And 7r is going to equal to 40. Dividing both sides by 7. R is equal to 40 divided by 7. This cannot be reduced, so this is one possible solution for R. We're going to now do the second equation, and these operations that we perform are the same. The inverse operations we perform are the same. So we're going to subtract 1 from both sides, and 7r is going to equal to negative 42. Dividing both sides by 7, r is equal to negative 6. And there's your two solutions. So either r is equal to 40 over 7 or negative 6. Let's move on to number 3. For problem number 3, let me change the pen color. I got a little tired of black, so let's use blue now. So we're going to do the same thing. Again, the absolute value of all of this, the absolute value of 10v plus 5 has to equal to 55. So that means either that 10v plus 5 is equal to positive 55, or 10v plus 5 is equal to negative 55. So we'll solve the two equations. That inverse operation dictates that we would have to subtract 5 from both sides. So 10v is equal to 50. 55 minus 5 is 50. And dividing both sides by 10, v is equal to 5. We do the same thing for this. We subtract 5 from both sides, and 10v is equal to negative 60. We divide both sides by 10, and v is equal to negative 6. So for this example, we're doing the same thing again. So we'll get negative 7x plus 4 equal to positive 60. And then we'll get negative 7x plus 4. And that either also, or that's going to have to equal to negative 60. So as you again clearly see, what we're doing is simply getting what's inside the absolute value and equaling to the positive and negative version of that number right there, or what it's equaling to. And then we just simply solve the two equations that we have. So we will first use it in inverse operation tells us that we would have to subtract 4 from both sides. So negative 7x is going to equal to 56 dividing by negative 7. X is going to equal to negative 8. And now we do the same two operations as we did right now. So we're going to add 4. I'm sorry, not add 4. Inverse operation is to subtract 4. We're going to subtract 4. So negative 7x is going to equal to negative 64. And we're going to divide by negative 7. Now, on this example, 64 cannot be divided by negative 7 because, well, it doesn't go in evenly, okay? It doesn't go a whole number of times. And they don't have a common factor. 7 is a prime number, so the only thing that we could do 7 is 7 and 1. So we can't reduce it any further. However, since there is a negative, hold on, let me erase that circle. However, since there is two negatives there, this one and this one, we can reduce those negative signs. Those negative signs can actually divide each other out. And x is equal to a positive 64 divided by 7. So here are the two solutions that we can plug in for x. So we end up plugging in negative 7 or 64 over 7. Now for number 5, we'll do the exact same thing. So again, we would plug in here negative 7n minus 5 is equal to 75, or negative 7n minus 5 is equal to negative 75. Now the inverse operations to solve these is to add 5 to both sides, and we get that negative 7n is equal to 80, and dividing by negative 7, n is equal to a negative 80 divided by 7, 80 over 7. Now inverse operations for this one, we would add 5 to both sides. Now notice that we're not getting negative 80, okay? We never get the opposite of what we originally had. So like here we get 80, over here we're not going to get negative 80. I hope you've been paying attention to that, because those are very common mistakes. Everyone thinks that you're just going to end up with the opposite number as before, and somehow we're going to end up with positive and negative of the same values. But no, on these examples, a little bit more complex, so we end up getting something different, okay? So now moving on, negative 75 plus 5, that's equal to negative 70. Now, the inverse operations of multiplying is to divide. So we're going to divide by negative 7. and n is going to equal to positive 10. So those are the two possible values we could substitute into this expression. Now for number 6, 5x minus 5 is equal to 25, or 5x minus 5 is equal to negative 25. So solving two equations, the inverse operation would be to add 5 to both sides. So 5x would equal to 30, and dividing by 5, x would equal to 6. Now here we would do the same thing. We would add 5 to both sides, and 5x is equal to, well, negative 25 plus 5, that's equal to negative 20. And then dividing by 5, x is equal to negative 4. There you go. Okay, so these are your two solutions. Now number 7, 9x plus 6 is going to equal to 21, or 9x plus 6 is equal to negative 21. So we would subtract 6 from both sides, and 9x would equal to 15. We divide by 9, and x is equal to 15 divided by 9. Here, we subtract 5 from both sides, and 9x is equal to negative 27. We divide by 9, and x is equal to negative 3. Now in this example, again, we get what's inside, negative 9m plus 6, and equal it to 60. And then we also set it to negative 60. So the inverse operation would be first to subtract 6. So negative 9m is equal to 54. 54, and then dividing by negative 9, 54 divided by 9 is equal to 6. We subtract 6 from both sides, and negative 9m is equal to negative 66. We divide by negative, oh, hold on. Let me go back to the previous answer. The previous answer should be negative 6. I'm sorry. Negative 6. Positive 54 divided by negative 9 is negative 6. I'm sorry about that. And going back to this one right here, again, like I said, I was dividing by negative 9. And m is going to equal to positive 66 over 9, but that's reducible. No, I can divide both of these numbers. I can divide the top and the bottom by 3, maybe not by 9, because 66 cannot be divided by 9, but they do have a common factor of 3, so I can divide both of them by 3. And because they both have negatives, dividing two negatives makes the number positive. So we end up with 22 divided by 3. That would be the reduced form. Now in the back, we have to do a couple steps before we can again split it up like we did on the first side of this assignment. Here, notice that the absolute value is not isolated, okay? So what we need to do is get rid of the operation being performed to that. So since we're multiplying by negative 4, what I need to do first is I need to divide by negative 4. So I need to divide by negative 4 to isolate those absolute values. So these two operations cancel each other out. And then we have the absolute value of r plus 5. And that's going to equal to 56. Let's see, 56 divided by 4, that's equal to 14, positive 14. Okay, so now from here, again, we can do what we're doing on the previous page. So we're looking for some number that when I take the absolute value, I get 14. So what that simply means is that I get what's inside the absolute value, the r plus 5, and equal it to either positive 14 or that r plus 5 has to equal to negative 14. Because again, the absolute value of positive 14 is equal to 14 and the absolute value of negative 14 is equal to 14. So I need to get what's inside this right here and either equal it to positive 14 or equal it to negative 14. So solving the equations, if I subtract 5 from this one right here, I get that the value of r is equal to 9. And if I subtract 5 on this one, I get that the value of r is equal to negative 19. So these are the two possible solutions that I have. So for number 10, again, I'm going to do the same thing. Notice that I have the absolute value, all right, of n divided by 6, but then I'm adding 1. So what I need to do is, since this 1 is on the outside, okay, I cannot like add it or anything inside. I cannot do some type of operation. So what I need to do is use inverse operation. So I'm going to subtract the 1 from both sides. Subtract that 1 from both sides. And that then isolates the absolute value. So n divided by 6 is going to equal to 1. So this means one of two things. Either n divided by 6 is equal to positive 1 or n divided by 6 is equal to negative 1. So to solve this, inverse operation would be to multiply by 6. So I multiply both sides by 6. And n is equal to 6. And I do the same thing on the other one. I multiply by 6, and n is equal to negative 6. So two solutions. Here, in order to isolate this absolute value, what I would have to do, since I am dividing by 8, is to multiply by 8. That way this operation and this operation can cancel each other out. And then that isolates the absolute value. So the absolute value of 9b would be by itself. But of course, what I do to one side, I have to do it to the other. So I have to multiply this side also by 8. So the absolute value of 9b is equal to 24. So what I do now is that I get what's inside the absolute value and equal it to positive 24, or I get the 9b and equal it to negative 24. And I simply solve the equation. So I'm going to divide by 9. And it's now reducible. 24 and 9 can't be divided wholly. So I could just find a common factor. Both numbers can be divided by 3. So I can reduce it by dividing both of these numbers by 3. And I get 8 over 3. So that's one solution. Now I do the same thing over here. I divide by 9. And I end up getting simply negative 8 over 3 this time. So, yep. Here, looks like for the last two examples, I got pretty much the same number. Just the opposites. I got opposite numbers as solutions. But not for number 9. Number 9 did not give me opposite solutions. Now for number 12, I have to do the same thing I did on number 10. I have to get rid of this constant so I could isolate the absolute value. So I would have to first add the 9 to both sides. Then the absolute value of b divided by 4 is equal to 1. So this means two things. Either, again, this is inside here. What I just highlighted, b divided by 4, that's either going to equal to positive 1 or that b divided by 4 has to equal to negative 1. So this is what we do. We isolate it as if we're trying to write it as when the what was on page number 1 on this assignment. And now we could split it up into the two things. Now solving, we would now just solve the equation. So here we would multiply by 4. So b is equal to positive 4. And here we will multiply by 4. and b would equal to negative 4. So here are your two possible solutions. B is equal to positive or negative 4. Now moving on to number 13. Now the one thing again, and I didn't mention the first time we did the I didn't mention it on number 9, but I'll make sure I mention it here on number 13. I cannot distribute, all right? The parentheses does, again, like I mentioned in class, prevents me from distributing this negative 5 into the absolute value. So what I need to do is use inverse operations to get rid of it. So I have to divide by negative 5. Those two operations cancel each other out, and I have that the absolute value of x divided by 10 is going to equal to negative 2 divided by 5. I'm sorry, positive, not negative, positive. Positive 2 divided by 5. So again, what happens now is that what's inside here, that x divided by 10 is either going to equal to positive 2 over 5, or that x divided by 10 is going to equal to negative 2 over 5. So the way that this gets solved by inverse operation is that we multiply by 10. So this operation cancel each other out, and x is going to equal to 4. 2 over 5 times 10, that's equal to 4. And I do the exact same thing here. I multiply by 10. And x is going to equal to, again, these two operations cancel each other out, and x is going to equal to negative 4. So here are your two solutions. Now here we're going to do the exact same thing. Before, again, I cannot multiply over here or reduce this 7 by this 7 because of the absolute value symbol, so that cannot be done. So what I need to do is use inverse operation. So I'm going to divide both sides by 7 because of that one right there. All right, so these two operations cancel each other out, and what I have left is the absolute value of m divided by 7 is equal to 3 over 7. So again, we then get what's inside the absolute value, m divided by 7, and equal it to 3 over 7. And then we get m divided by 7 and equal it to negative 3 over 7, and solve. So just like the previous example, the inverse operation would be to multiply by 7. So that way these two operations cancel each other out, and m is equal to 3. 3 divided by 7 times 7 is equal to 3. And we do the same thing here. These two things cancel each other out, and m is equal to negative 3. So here are your two solutions. Now for number 15, the inverse operation, again, to perform here to isolate the absolute value is to subtract 7 from both sides. So that would cancel that operation out, and then that isolates the absolute value. And we get that the absolute value of negative 4x is equal to 8. So what we do again is get what's inside the absolute value, that right there, and we get negative 4x and equal it to positive 8. And we get negative 4x and equal it to negative 8. Inverse operation dictates that we would have to divide by negative 4. And x is equal to negative 2. And over here, dividing both sides by negative 4, x equals to positive 2. So those are your two solutions. And then finally, our last example. In order to isolate this absolute value, this whole thing right here, we would have to add 6 first to both sides. So then the absolute value of k minus 10 is equal to 20. So again, the whole idea is that this, what's inside the absolute value, that either has to equal to 20 because the absolute value of 20 is 20, or let me change the colors, or what's inside here, that has to equal to negative 20 because the absolute value of negative 20 is also equal to 20. So again, that's exactly what we're going to do. We're going to get, let me just write it again. We're going to get that k minus 10, what's inside again, is going to equal either to positive 20 or this k minus 10 has to equal to negative 20. So adding 10 to both sides, we get that k is equal to 30. And adding 10 to both sides of this equation, we get that k is equal to negative 10. So there's our two solutions. Now again, thank you for watching. If you still have any questions or any concerns, please again come and see me. Now again, we have tutorials on Wednesday, and have a good day for thank you again for watching and have a good day.